Detailing a wall, or walls especially, is an example of the type of job that you may want to do with just as few distractions as you can arrange. Maybe come in early. Maybe do it on a Saturday morning. Maybe turn the radio off, or whatever you've got to do so that you will not lose your focus, because detailing a wall is so easy in terms of the labor it takes to do, but a mistake in the detailing can make a very time-consuming and expensive repair if you have to tear stuff apart, change locations, change sizes, change heights. It can just get out of control in a hurry. So you do not want to make a mistake in your detailing, and so do whatever you have to do so you can really get into the zone. Detailing is the process of marking the plates in a way that anyone could use if they came back and tried to assemble the wall. There are a lot of items that I'm marking here. Openings, that is, windows and doors, and the components of the windows and doors. Channels, beam pockets, headers, studs. At the end of this video, once we have a couple of walls on their feet and in place, I'll walk you through the different parts of these wall assemblies when I can point right at the piece, show you what they look like, and give you their name. Every single wall in this house is different and will receive a different treatment. So after the plates are detailed and you've labeled them carefully, you've got to label them carefully or you'll never figure out where they go, days from now. Carefully move them out of there. Stack them up out of the way. Because as you can see, the deck is an important work surface. It's a giant template at this point, and you need to clear the space to assemble the walls. Now, if the detailing was done right, the assembling should be pretty easy. Spread out all the material, make sure it's all available, make sure the stud lengths are right. You've really got to make sure your stud lengths are right before you start nailing them together, and then put everything in place. This rigging axe was given to me by a viewer, Dave Taylor. Now, he's also given me a lot of good information, some of which I will be using. But this is the first time I'm using the axe that he found and purchased for me. I used a rigging axe just like this, a plum rigging axe, 24 ounce, in Vegas, and it was my daily driver for years. There was not any hammer available to me then that could drive nails the way that axe did. And when you get used to it, it's really effective at, pulling nails and breaking bands and just all kinds of things that a hammer just doesn't seem to be able to do in quite the same way. I'll talk later about the reasons a hammer like this makes a lot of sense for certain framers, and I'll give a review of this one in particular because there will be a lot to say. But for now, I'm hand nailing these things together just for the fun of it, and to see what it feels like now that I'm 61 compared to when I was 31, and to try this tool out for this type of work after all these years. The fact is that it's fun to nail a wall together, And the other fact is that nail guns are faster and easier. Nail guns are what we use for most applications for this type of work nowadays. But that does not mean a hammer is obsolete. You got to have one on you at all times when you're assembling walls. You know, tapping into place or pulling a nail or prying or spreading or lifting up or, tacking things together, tacking on a brace, setting a nail that didn't quite get set if you ran low on air pressure. All these things are things that only a hammer can do. And so, as much as we might think it should, a nail gun does not replace a hammer. Now, I like to put 3 nails through the plates in a 2x6 wall. 3 through the bottom plate and 3 through the top plate. Code, I think, is 2. So this is a step beyond what would be acceptable. They're 16 penny nails, which means they're 3 1/4 inches long. And in my opinion, adding more nails, beyond the 3 anyway, doesn't do much of anything for the strength of the wall. So there's certainly no need to get carried away. The real strength of this wall and the connections that hold it together happen with the shear panel. The 1/2 inch OSB that's nailed on the outside with 8 penny nails on very close centers. That's what really ties this wall system together. The nails through the top and bottom plate pretty much just hold the boards in place until that shear panel is applied. And as far as I know, the engineer does not attach any real value to these 16 penny nails, but he does attach real value to the shear panel. So not only is a nail gun faster, no matter how good you are with a hammer or an axe, but more importantly, a nail gun allows you to be more accurate with your assembly. You can hold a stud or a cripple or a header exactly in place while you pull that trigger, and the nail goes in instantly. You can't really do that with a hammer. There's a little dance you have to do to start the nail and hold the cripple and hit that nail hard enough to slip it into the cripple quickly, capturing it before it has a chance to be jarred out of alignment by the vibration of the hammer blow. There's a real trick to it, and there are very few tricks to actually using a nail gun. Mostly just keep your fingers out of the way. Now, if you're wondering why I'm fooling around here marking another board when I already have a top plate and a crown plate in place on this exterior wall, it's because I'm matching the layout for the joists that are going to sit on this wall on the crown plate that I'm going to put on the other side. I want these joists to go across this building perfectly parallel. And it just cuts out the opportunity to make some sort of a math mistake or an oversight and not paying attention, or whether the joist lays ahead of the mark or behind the mark. If I just copy what I did on one side of the house and then carry it across to the other side and nail it in place, I know that they're going to match. I could have done all this with the walls up and in place, standing on ladders or walking down the plates, and that is slow and painful, and so it just seems to me it's kind of a time saver to do as much of this layout as you can on the ground. My engineer, Dave Thomas, gave me the latitude to decide for myself whether to use 5.5 by 9 inch glulam beams for the headers or build a box header. A box header is something you will see later. It's a header that's made up from 2 pieces of 2x, either 2x8, 2x10, 2x12, nailed together on either a 2x4 or a 2x6, depending on the wall thickness. And even though it was probably a bit more expensive, I went with the glulams because it is simple. It reduced the chance of any failure because of defects in a board. They don't twist or warp in the sun the way 2 independent boards can. And you don't, have the risk of defects or wane or knots or pitch seams lining up and creating a flawed header the way it can happen with a box header. It's faster also. I mean, that's the bottom line. It's faster to just cut one of these guys and drop it in place. And since we have a lot of headers happening in this house, I decided to be consistent in the interest of productivity, and I think overall I came out, ahead, or at least even, doing it this way. This is a perfect wall for lifting with jacks. A wall jack gives you real control when you're lifting, and nobody's straining themselves. And you can bring it up incrementally, and you can keep it in a plane, and if you're careful with your bracing, it won't fall over off the deck when you get to the top, and all those things being true. It still introduces an element of risk, though, especially these old-fashioned devices that climb up a 2x4. If you expect a wall jack climbing a 2x4 to lift too much weight, you're setting yourself up with just a really nasty mousetrap. I mean, think of what would happen if this wall was lifted with maybe 2 jacks instead of the 4 that we're using, which I will admit is overkill. But nevertheless, if we just used 2 and one of them failed somehow, there's just no way to get out of the way before you're smashed on the deck. So we're taking it easy. And you'll notice that when it gets up too high for us to operate fairly effortlessly, we put a ladder up, which, were the jack to fail, the ladder and the operator would be pushed back out of the way rather than being pinned under the load. So make sure the bottom of these 2x4s are backed up so they can't slip. They're nailed down so you can have confidence in them. They've got to be able to change their angle as the angle of the wall gets closer to vertical. The angle of the jack will get closer to horizontal. Pay attention, use your head, and they're terrific.
Keep it coming. Hold it. Slack. That's it. Hold it right there. Perfect. So we'll accept it.
I hope you're enjoying our house building series here. You may know, if you've been watching for a while, that we're making all the costs of this house known to our supporters. Our supporters are lots of people who are donating just a few bucks a month, but it makes a big, big, big difference in our ability to create this content. Now, there are a lot of different costs that make up the framing portion of this project. Primarily lumber, of course, but not all lumber is created equal, and not all lumber is priced equally, and so these things are interesting. And like I have mentioned, the lumber is coming from lots of different sawmills and manufacturers, lots of them, several of them local, but all of the lumber is being purchased through our local building material supplier that I've been using for 25 years, Garrett's Building Supply. They have relationships with these various mills and manufacturers, and they are going to be delivering lumber for the entire framing process. And they'll be delivering siding, and windows, and doors, and trim, and all sorts of stuff. It is important, in my opinion, to have a relationship with a full-service lumberyard. They will solve problems for you that you didn't even know you were going to run into. And yes, the box stores have their place and they have their purpose, and sometimes you've just got to go in there. I get that. but it's just not the same as somebody who specializes in quality materials for a quality project. Not the same at all. We will be posting basically our invoices from Gerritson's so you can actually see what we paid for this lumber. Eventually, we will take the time to break it out into the various segments and phases and pieces and types, but that's going to take a while because right now we are building a house and not concentrating on our accounting. So please be patient. And if you're watching this as a supporter as we build it, thank you so much. You really are a part of the team. And hang in there. It's been a busy summer, and we'll catch up with these details as soon as possible. It's probably obvious why doors and windows, the openings that are in your house, have to be in specific locations. For instance, this is a kitchen window. There's a particular distance that the cabinets will occupy on this side. There's a particular location for the dishwasher to the left of the sink. The sink is a specific width. All these things tie into where this window happens, and where this window happens ties into all those things. Beyond that, the plumbing has to come up in a particular spot to service the sink, which is centered in the window. So not only does the window have to be in the right spot left to right, but it has to be in the right spot up and down because of where the countertop will come in and how the edges are going to be treated, where the backsplash rolls into the glass. So this is just one example of why detailing the plates very accurately can be absolutely critical to whether or not your building actually works when you get it built. Let me show you what some of these components are and what they're called, at least on the West Coast. First of all, and the part of the window that's working the hardest, is the header. In this case, this is a glue-lam beam header. I'm using those almost exclusively throughout the building. The header is holding up the joists and the roof, and who knows what else is going to be loaded on this header. So it has to be strong. But the header is holding up the load. The trimmers are holding up the header. This board that comes up from the bottom plate and holds up on the bottom of the header is called a trimmer. Any opening over about, in my judgment, 6 or 7 feet, let's say 7 feet, should have a double trimmer, so you have a larger surface area resisting that compressive strength, that compressive load of the header being pushed down. The trimmer is fastened to a king stud. A king stud is a stud that goes all the way from the bottom plate to the top plate, fastened to the layout, secured to the end of the header with back nails. The trimmer is held to the king stud, and the king studs determine and hold the whole window assembly in its location. Any stud that is interrupted by an opening, either above the opening or below the opening, is a cripple. The top cripples transfer the load from the top plate down to the header. The bottom and provide backing for sheetrock and siding and, establishes the diaphragm above the window. The bottom cripples span the distance from the sill, this is the bottom sill, down to the bottom plate. They hold the sheetrock, they hold the siding, they are not doing much work except holding those surfaces because there's not much of a load on this bottom sill. So if you're paying attention and watching closely, you may be asking yourself, why has he got 2 king studs on this side and 1 king stud on this side? Do you remember those bolts, those big bolts that I had suspended into the block stem walls? Those are hold downs. Those are seismic hold downs. There's about, I don't know, 1 million or 1.5 million of them in this building. And one of them happens right here. In order for that hold down to develop the strength that it needs to develop in the shear panel that's going to be right here, a shear panel is any part of a wall that is reinforced by the sheetings, the sheet goods, or blocking, or bracing, so that it resists lateral twisting or overturning moments, gives it shear strength. The shear panel happens between this hold down and one that's in that corner. The shear panel has to have doubled members at the hold downs at the edges so that the nailing schedule can get up to the strength that's needed. So I have 2 king studs and a trimmer, a bottom sill, bottom cripple, header, top cripple, top plate, and crown plate. On this side, we have the trimmer, single trimmer, and 1 king stud. I have a hold down over here that is using the king stud and the trimmer as the 2 members. So there's a slightly different treatment, but if you're going to be inconsistent on the side of making it stronger rather than weaker. There is a really, really big deal here that I want you to think about really hard, and that is, even though your plans will give you the window size, the plans are not, the architect or draftsman is not giving you the rough opening that your window manufacturer may need for a window that size. Different window manufacturers have different callouts, different details in the sizing, the actual size that they have to have for their actual window to go in. A 5040 window by one manufacturer may require a different rough opening than a 5040 window by some competing manufacturer. And so you have to know who you're buying your windows from before you detail the plates for a particular window opening, or you're going to have a lot of painful tear out and rework when the real windows get there and you realize, whoops, they don't fit into that opening. Or not so painfully, whoops, I need to fur down this opening to accommodate the actual window size that I ended up purchasing. The same thing is true with the doors. If you're not really conversant with rough opening on doors, which by the way is not the size that is called out on your floor plan when you're looking at a 2.8 door or a 3.0 door, that's not the rough opening. And different manufacturers sometimes have slightly different heights, although it's usually pretty standard, around 6'10" on the rough opening. But call your doorman and say, okay, I'm ready to order these doors, but let's go over these rough openings one more time. You'll not be sorry. There's more to say about plating and detailing, but for now, I just want to jump to really the biggest piece when you look at a structure standing on its feet, and that is the common stud layout, whether it's 16 inches on center or 24 inches on center. And before I talk too much about that, let's just talk about what a stud is doing. It's holding a little bit of vertical weight. Not a great deal. It's holding whatever average load kind of is spread across the whole wall diaphragm. It's not doing what a header's doing, where it's holding the weight of, 3.5 or 4 feet. It's just holding whatever is on each side of its layout. More than I want to hold, but not the whole world. So strength is not the only thing. What a stud is doing mostly is providing a nice flat surface to nail the drywall to on the inside and the siding, the shear panel, the subsheeting, the siding to on the outside. It's mostly a nailer. And so most of the consideration about putting common studs in is making sure that they are more or less in the right place for the people that are going to come in and nail up those surfaces, or the carpenters that are on the outside nailing on the exterior surfaces. With this understood, that a stud is mostly holding up vertical surfaces and providing nailing, you understand that while the location needs to be specific for the convenience of the installer, it's not always the hill to die on. What I mean by that is, with your openings in place in the wall, when you're laying out your common stud layout and you come to a spot where, let's say, a trimmer and header, a trimmer and king stud assembly holding up the end of a header is close to layout, maybe you don't have to throw an extra stud in here, because after all, it'll just be an 1.5 inch overspan on the sheeting. The drywaller's going to come across here and he'll know where the backing is anyhow, so it's not very confusing. Maybe you leave a stud out right there if your common layout happens to throw one in. Now it didn't at this point, but we're talking in, theoretically. Or when you're putting your top cripples in, is that an overspan? That looks like that might be an overspan right there. It looks like 16 inches on center would have maybe required one in here. I didn't check that. But it's not a big enough deal to be worth cutting the board and putting it in, because after all, the drywall will nail at the top and the bottom, and it'll be nailed down the side of the window, and it makes no difference. But what does make a difference is it's starting at the edge of the building. You shift the stud 3/4 of an inch so that 16th inch layout hits in the center of the stud and not on the edge. Your sheet goods, whether it is the plywood on the outside or the drywall on the inside, come in 16 inch or 2-foot increments. And you want the ends of those sheets to break or stop in the center of the stud. So here is the thing that you're keeping in mind when you're detailing these plates. You're putting openings in the place that makes the opening work, and you're putting studs in the place that makes the stud work. The stud has to work for the drywall and the siding. So as you're laying out your studs, be thinking like a drywaller, or be thinking like you will be thinking when you're putting the siding on, so that the center of the stud occurs at the edge of the sheet. Now, having said that, you will have the capability of cutting the drywall. The subsheeting and the siding can be cut, but you don't want to have to cut every sheet. You want to get what is called free sheets. That is, where the expanse is wide enough and the stud layout is regular and the 16 inches on center is working beautifully, and you can just pick the sheet up and put it on the wall and you have backing everywhere. But you can't always do it. But you try to, because after all, we like to play nice for the people that are coming along behind us. Framing a house is an interesting thing because each individual task in framing is easy. I mean, it's just, there's not much to the individual things that you do with a saw and with a hammer and with, even with your calculator, none of it is that complicated. The complicated part of framing a house is thinking of the whole structure as a system, that the whole structure has to work together. And the individual tasks that you're doing are one little tiny bit of effort that will result in its contribution to the whole system. If you can't learn to think of it that way, it's impossible to tell how what you're doing may be not the right thing for the whole system. You can get so locked into the moment that you lose sight of where you're going to be 2 weeks or 2 months down the road. I bet it's much more complicated for you watching this series than it is for a new carpenter walking onto a job where at least he can see everything all at once. Once you get to the end of this go back and watch it another time or two, the individual choices that we're making and explaining about framing are going to become much more coherent. Most of the really embarrassing mistakes that I made as a young carpenter framing was because I hadn't been around enough to know how my individual task and the way I was doing it was actually causing a big problem 6 weeks later. That's the challenge of framing a house, is working today in a way that's not going to compromise the process months from now. As an example of this, when I was showing you and when I was locating the hold downs in the stem wall that we were grouting into place, I think I talked about understanding where the window opening was and the king studs and the bottom cripples and the trimmers and the back set on the hold down itself so that the hold down would end up in the right place. Well, as it turns out, I missed it by 1/2 inch on this side, and I got it exactly right on this side. But it was hard to explain and probably impossible for you to follow in the moment. And now, well, it's just clear. Anybody can figure that out, right? Once you've seen it go together. So that's the challenge for you watching this series, is to keep up with the explanations well enough that it piques your interest, and then maybe circle back around and keep track of what you were wondering about and see it when it's installed and see how it works with the other components of the system and the other trades and have an aha moment. Okay,
I see now why those top cripples had to be spaced like that, or I see now any number of things that are impossible to explain but will be easy to understand. Really, the thing to keep in mind is that the entire house is an integrated system, hopefully a fully functioning integrated system. And framing is establishing the bones. We're putting the bones on the foundation that will hold the structure in place and doing its job for decades and decades to come. Thanks, as always, for watching Essential Craftsman, and keep up the good work.